Hello everybody and welcome back to another math learning video. Today I brought you guys this problem here where we are tasked with finding the maximum and minimum of this equation here. F of x is equal to x cubed minus 6x squared plus 9x plus 1 on the interval of 0 to 5. So remember, these square brackets means that we're including 0 to 5 in our answer, so the max and min can occur on 0, 5. So how do we go about solving this problem? Well, let's ask, what is it asking us to do? So let me try to draw this out. So we have a function here, right? This function moves somehow. This is not how the function looks like. I'm just drawing a fake function here. And then on the intervals of x equals 0 to 5. So in this interval here, we want to find the maximum. So what the highest value of the function is. So the highest y value. So maximum in my theoretical sketch here is here, right? This is the highest where the graph goes, and our lowest value. So we want to find this value here. So how do we go about and do that? Well, to do that, we need to find what are called the critical points of our equation, of our function. So the critical points are when you set the derivative of f of x. So derivative of f of x prime is the derivative of f of x is f prime. We want to set this to 0 because remember, the derivative of function shows how much the function is increasing or decreasing. So when the derivative is equal to 0, this means that the function has either stopped increasing or stopped decreasing. So if it stopped increasing, that means it has reached a peak, right? So function has reached the peak, is increasing until the derivative, until the slope is 0, because then it stops increasing again. And then it could either go back down, which means that its peak is exactly at the point where it stops increasing. So the derivative is 0, so f prime of x equals 0. Or it can be the other way around where it's decreasing. It keeps on decreasing until the point where it stops decreasing, where the derivative is equal to 0, the slope is equal to 0. And then it comes increasing again. So this point would give us a maximum, and this point would show us where a minimum is. So we need to go ahead and find these points and then plug it in and see what their values are. So let's go ahead and find what f of prime of x is in the first place. So f prime of x is equal to, so remember, now we have to find the derivative of this function. So how do we find the derivative? Well, we have for our first value, x cubed. What you do is you bring down the exponent and you multiply it in front of your variable. So here our exponent is 3, so we bring down the 3. So we put the 3 here. So we have 3, and then our variable stays here. 3x, and then our exponent now is the same exponent minus 1. So instead of having exponent of 3 here, we have exponent of 2. And then, so that's how we do that. So now for our minus 6x squared, so we bring down the exponent first. So we have negative, then we have 2 times 6, so that'll be equal to 12, right? And then x, and then remember our exponent subtracted by 1, so we have x to the 1. X to the 1 is just equal to x, so I'll leave it like this. And then we have here 9 to the x. So remember, if there's no exponent, x is also the same as x to the 1. So the way you can imagine this, you can bring down the times 1s. 9 times 1 is still 9. And then our x to the power of 1, subtracted by 1, you get x to the power of 0. X to the power of 0 is equal to 1. So this would just be 9 times 1, which is 9. And then our 1 does not have any variable, so whenever you find the derivative of it, you just cancel it out. So you don't use it, it just disappears. So now we have found our derivative, f of x, and now we want to find when f of x is equal to 0, or when f prime of x is equal to 0, because that will then show us where the function has reached its minimum and maximum. And remember, can be multiple points where it reaches minimum and maximum. So what we want to do then to find the total minimum, total maximum, is just plug all the values that we find and then find which value gives us the highest and which value gives us the lowest, okay? But first we need to set this equal to 0. So 3x squared minus 12x plus 9. So I already see there's a factor here that I can factor out. If I divide everything by 3 on both sides, I get x squared minus 12x, no, not minus 12x, sorry, minus 4x plus 3. Okay, and this is equal to 0. So now to solve for x, we need to factor this, okay? So how do we factor it again? So the way I was taught it, you can make an x here, and then on the top, we want to find a value that is equal to the first coefficient. So here there's no coefficient here, so this is just equal to 1 times the last value here, so times 3. So we need to find two numbers that multiply to 3 and add to the middle number here, add to negative 4. So which numbers multiply to 3 and add to negative 4? Well, the answer is negative 3 and negative 1. So then, for factoring, we just write out x minus 3 and x minus 1. This is equal to 0. So now, in order to make these equations equal to 0, we can plug in x equals 3, because then if x equals 3, we have 3 minus 3 here, so that'll be 0 times this, which is 0, or x minus 1. Okay, so these are our so-called critical points. And now we can plug them in to find out where the maximum and minimum are. It is also important to note that when wanting to find the maximum and minimum on a certain interval, we also want to plug in the endpoints to see if they could be the maximum and minimum of the function on the interval, because, for example, if you have on 0, 5, right? If this function were just decreasing forever and then starts increasing here, its maximum would be at the point here, which is at the boundary, so x equals 0. So therefore we also need to plug in 0 and 5 to see, because they could also be the positions of the maximum and minimums. So I'm just going to add these to the list of numbers that we're going to plug in. So now we simply just plug in every number into the original f of x equation and then see which value gives us the maximum, which value gives us the minimum. So first, let's just plug in x equals 3. So f of 3 is equal to 3 cubed minus 6, 3 squared plus 9 times 3 plus 1. So 3 cubed is 27 minus 6. So 3 squared is 9. 6 times 9 is 54. Plus 9 times 3 is 27 plus 1. Okay, so 27 plus 27 is coincidentally 54. And then minus 54 plus 1. So 54 minus 54 is just 0, right? So then we get that f of 3 is equal to 1. So now let's plug in f of 1. F of 1 is equal to 1 cubed minus 6, 1 squared, plus 9 times 1, plus 1. So that'll give us 1 cubed is just 1, minus 6 times 1 is minus 6, plus 9 simply, plus 1. So it gives us negative 5 plus 10, and that gives us 5. So we got that f of 1 is equal to 5. So now we have two more values for us to plug in. So 0, remember this is the boundary point. You always check the boundaries, okay? So then 0 cubed minus 6, 0, plus 9, 0, plus 1. So this is 0 minus 0 plus 0 plus 1. So you get f of 0 is equal to 1. And now, finally, we plug in 5, our final value. Remember, another endpoint. So f of 5 is equal to 5 cubed minus 6 times 5 squared plus 9 times 5 plus 1. So 5 cubed is 125 minus 6 times 25, which would be 150, if I'm not mistaken, plus 45 plus 1, and then that gives us negative 25 plus 45 plus 1. So that will be negative 25 plus 45 is equal to 20 plus 1 is equal to 21. So f of 5 is equal to 21. So now we have plugged in each of our values, and now we can determine which is the minimum and maximum by simply just looking at the values. So now, just looking at them, we see that our maximum is at x equals 5, and it's the value of 21. And then our minimum is at 2 places, actually, at f equals 3 and at x equals 0, because both of them give us a value of 1, which is the minimum on this equation, okay? So that is it for today. So thank you guys for watching this video. I hope you guys enjoyed it, and see you guys next time. Bye.